Hey, in this one I'm going to show you what are proxies in ZeroMQ. And so let's just start with what is the problem that proxies try to solve. So let's say you have a complex application with a lot of publishers and a lot of subscribers. And so you have multiple services, a lot of them are publishing stuff, a lot of them want to subscribe to this stuff. But then you run into a discoverability problem because each of those publisher service might run on different ports, they might run on different machines, and so on and so on. And so that would mean that you would have to keep a list of all the available publishers for each one of those subscribers, or keep a list of what subscriber subscribes to which one, and so on and so on. And so what you would like to do is have a single address, a single port on which any of those subscribers can subscribe. And through the proxy, this subscriber bar, for example, can subscribe to this publisher bar and ignore the other ones. And the subscriber foo can subscribe to the publisher foo and so on. Or the subscriber foo can subscribe to foo bar baz, but not the last one. Stuff like that. And so yeah, this is what we're trying to solve with ZeroMQ proxies. And so I've done a little example here where I try to replicate what I have in the diagram. So I just have a publisher with a that sends whatever I say in the first argument, and then I have a subscriber which does the same. It just subscribes to whatever is in the first argument. And you can see that in the next window I have this running. So I have a subscriber foo, a subscriber bar, I have a publisher foo, a publisher bar. And so for now, none of them are connected to anything. So let's try to solve that. Because the subscriber doesn't know the address of the publisher and so on. So let's go in the proxy, like so, and what we're going to use is something I've described in a previous video, which is called xsub and xpub. And a very quick rundown, the only difference between xsub and xpub and the non-x version is that the subscription and unsubscription messages are actually they're actually forwarded to the user or forwarded to the application. It's not done under the hood. So we're gonna create two of those. Xpub, xpublisher, why not? Is gonna be a ZeroMQ socket with the context and ZeroMQ xpub, like so, and we're gonna have a x subscriber, like so, sub. We're gonna destroy those, x publisher, x subscriber, like so. And now, now we can bind those to some interfaces, like so. So the publisher will be listening on 81 and the subscriber on 80. And you can see that I bind my xpub and xsub. So those are the known endpoints in the network, and then the publisher will connect to the x subscribe, and the subscriber will connect to the x publisher. So you see that now, like this is the publisher connecting to a x sub, which is maybe a bit counterintuitive. Actually, the connect and bind can go either way, but in this scenario, it makes sense to have it like this. And so now we're gonna use the ZeroMQ a proxy function. And so what the proxy function takes as argument is the two first arguments are two sockets, a front end and a back end. Actually, it doesn't really matter, it's just philosophical, the difference between the two, but basically it will connect those two sockets, and anything that this one receives will be forwarded onto the other one. Anything that this one sends will be forwarded onto the other one, and so on. Basically, any receive and any send is forwarded to the other one. And so we're gonna do that the front end should be the X publisher, and the backend will be the X subscriber. Or the other way around. I'm not sure. The third argument we're gonna showcase later. And so now if I run this proxy, we should see that now it works. So both subscribers were able to connect to both of those publishers through the proxy, and they didn't have to know the address of those or the endpoint of those, and so on. So yeah, that's mainly what proxies are used for. I mean, you can use them with any kind of socket types, like router, dealer, and so on and so on. This is just the main use case I know about, because it's probably the most useful. But yeah, so anyway, now let's talk about this mysterious third argument, which is a capture socket. So what a capture socket is just a socket on which any traffic will be forwarded to it, just so that you can observe what happens inside of the proxy and maybe do statistics or send it to another applications or stuff like that to run some metrics on the message. I don't know. So let's create this a capture socket. I think the capture socket can only be a ZeroMQ pair socket type. We can bind the capture socket to anything. So let's just do inproc my capture. Let's pass the capture socket here. Let's close it here. Like so, nothing fancy. And so this will need to run in another thread. So let's just create that quickly. Capture thread. Thread creates into the capture thread, like so. We will have null as the attribute, then we will have capture routine as a function, and we will pass the context as the argument. And let me just copy paste the capture routine, it's not very complicated. So this will just be the function that is used by the thread. We create the other endpoint of the pair. We connect to the capture socket on the other end, and whenever we receive something on it, we just print it, and that's all. So let's rerun that, and you can see that now, well, the subscribers, they still work, like so, but now we also capture all the content that's going on. And you can see that there is some empty messages here, and those are the subscribe and unsubscribe message. So you can capture those as well, do statistics on those if you want. Let's kill the bar receiver, the bar subscriber, and now we should see only foo messages being forwarded. And so yeah, that's I think that's mainly it about the proxy of ZeroMQ. I could have as much publishers and subscribers that I want in this network, and it would still work. And yeah, I hope this was useful in case you need to solve this discovery problem in your applications, and I'll see you in the next one. See ya!